Okay, we're going to get started today, and I just wanted to welcome you to the session. I know the keynote ran over, so we're running about 15 minutes behind, but we're still going to just try to stay on this 20-minute schedule for all of these mini sessions. My name is Brandon Bray. I'm a senior program manager lead from the Common Language Runtime team, and we're the team that builds the, pretty much the execution engine or the runtime that underlies all of the .NET framework and now all of Silverlight. And so today I'm just going to go and talk to you about how we took the .NET framework and the history there and took the pieces that we build for that and slim that down to fit the Silverlight scenario. And through that, we're going to talk about why is .NET really the motivation behind using Silverlight, and the process of slimming that down, all of the new features that we had to build for core CLR, and then the future investments. And so one thing I'm going to make is an assumption that all of you have some moderate understanding of what the .NET architecture is. And this really means, do you understand the features of managed code? Something like, what is garbage collection and what is reflection and that aspect of things. Now, since this is a 20-minute presentation, I am going to leave some time at the end for people to ask questions. So I'll ask that you hold off your questions during the presentation. Write them down in your notebook just so that you don't forget them. And I'll provide some time towards the end for that. So with that, we'll get started right away and talk about why use .NET with Silverlight. The big answer to that really is the .NET has a strong developer community. If we were going to introduce a new programming model for the rich internet application space, it really isn't to our benefit, as an entire developer community to introduce a new programming model. And that itself is probably the biggest motivation. We have a great tool ecosystem. We have Visual Studio and compilers for C#, being able to compile, use the same modern languages that we've built, as well as our editors and other tools. Being able to reuse tools that we have for the desktop and WPF, such as Blend, is a great option. But I think the other aspect is that .NET has a standard, the Common Language Infrastructure, that's now been approved both by ECMA and the International Standards Organization. And that means that third parties and partners can build tools such as debuggers and profilers and other things that give you all that advantage. And then next, .NET has a lot of important and mature features. .NET is now about 10 years old. It's been in development for quite a while. It has security, code access security that lets you run partial trust code. And even prior to the introduction of Silverlight, we had the ability to run controls on .NET that in partial trust even in the browser. And so that's a programming model that already exists, and the technology is fairly mature. We also have another feature that goes along with the security model, is that we have strong type safety. And type safety has this incredible feature that if you keep two applications that are type safe and run them inside the same process address space, type safety guarantees that those two applications will not collide with each other. And that if I write into the memory of one application, it's never going to interfere with the other application. And that gives us quite a bit of opportunity. Since we know that these rich internet applications are going to be running inside the browser process, we want to be able to load multiple of these applications without having them conflict. A great example of that would be, I have my own website that's got interactive content, but I also have an advertiser that's potentially using Silverlight to show some interactive advertising. And I don't want the advertiser to have access to any of the data that I'm collecting through my website. So basic privacy there. So you might ask, well, if .NET is so great, why did we just not build Silverlight on top of .NET? And it comes down to a very simple answer is that .NET is not everywhere. We know that, for one, .NET is already a Windows-only option, but even on the Windows platform, it hasn't gained the adoption that we'd like to see quite yet, and that's something that my team is actively thinking about and working on. But a key contributor to that is the size of the .NET framework. .NET is 3.5 today, nearly 200 megabytes, and that's far too much for us to ask any website to say, go install this experience or this app, framework, so that you can just run a very small application. And a fair comparison, though, is actually .NET 2.0. The reason why 3.5 is 200 megabytes or getting there is that all of the libraries that are shipped with that include the 2.0 libraries as well as the 3.0 libraries and the 3.5 libraries. We do that for backwards compatibility. And going all the way back, and shipping every version is costing us. So 2.0 is actually closer to about 20 megabytes. And even at that, 20 megabytes is too much. The .NET architecture does include quite a few features, though. And we see that it really focuses on every developer scenario that we'd like to support overall. It has server with ASP.NET, client with WPF, partial trust and full trust. It has interop features. And where we look at the CLR, this yellow box at the bottom really is the part that we're going to talk about today. It includes features such as the base class libraries, those types that are part of the common type system, as well as the collections and other things that are essential to really building fundamental programs. We have the just-in-time compiler, an NGen service that helps us with load time by caching the results of our JIT compiler, and garbage collector, a security model, exception handling, our loader and binder, which really focuses on versioning, and of course our developer APIs. And if I asked anyone, what would you remove from this to make this smaller? Everyone would have an answer, but they're always going to answer from their point of view, the scenarios that they want to support. And today, with Silverlight, we're really focusing on one scenario, which is the rich internet application. And in this case, we can say that a rich internet application doesn't need the ASP.NET libraries, and it doesn't need all of the other things that come along with the framework. We really just need to focus on a few things. And so one goal that we have as a company, Microsoft, is we want the core CLR, the piece that's going to be smaller, that is part of Silverlight, to be built out of our CLR sources. And that gives us the ability to continue investment in the CLR and gain that within the core CLR. And the RIA scenario then goes, we don't really want to support full trust applications. When we download applications off the web, they're always partial trust. And we're not going to need all of the interop features that come with the full framework, because partial trust implies that I can't interop with untrusted code. Our versioning model is simpler. We don't need to ship every single copy of the history of Silverlight in order to do that. We need to employ different compatibility scenarios. And that also means that we need to raise our bar, that we don't make those breaking changes that imply that we need to ship copies of older libraries. And the last thing is that core CLR itself is only activated through the host. In the framework, we have multiple ways to activate the full CLR. And that would be through an executable. It could be through DLL activation or through COM activation, and a host. Host might be something like SQL Server. In this case, core CLR is only activated through a host, and the host for Silverlight is the Silverlight control itself. And so that leads us to the resulting Silverlight architecture. All of the features that were part of the CLR are still there. except in each of those blocks, from the base class libraries to the security model, we've taken the scenario approach and looked at what is really needed for the rich internet application and slimmed that down. So we still have all of those things, and we've gotten the core CLR down to roughly 2 megabytes. So that's quite a great achievement for us, and that has everything that we need. You'll note that the two things that are missing or changed in core CLR compared to the full CLR is that NGen is no longer available, and that at the moment profiling APIs are not exposed. And so I'll cover more about that shortly. We'll go directly now to talking about what each of these areas, how they slimmed down. And the first area is the base class library. We started off with the full framework, which is dozens and dozens of files. And now core CLR itself has 10 files. Most of them are managed files like system.dll and mscorelib. Core CLR.dll is the essential one that has our JIT and the other runtime components. And if you look in the directory for Silverlight, there are other files like agcore, which is the file that has the presentation layer for Silverlight, and npcontrol, which is the browser host. But the essential part here is that to slim down most of this, it had to come from the libraries. And the scenario that we have here is the small base class library, or the small BCL. It's built from the same sources as the full BCL. So again, as we continue to invest in the full BCL, we'll realize those benefits in small BCL every time Silverlight updates to a newer version of core CLR. And the other thing that we could notice is that some of the features of BCL are more important in the RIA scenario than they were ever for the framework. And isolated storage is one of those. So we can see that one of the things that we changed in isolated storage for the RIA scenario was better enforcement of quotas, being able to say how much space can someone take for a file. And an interesting thing that we learned there is we were a little too aggressive. We were saying that we wanted to enforce space as soon as we saw someone changing that through the Silverlight control. So if they said you no longer have 100 megabytes, you have 2 megabytes for space, to enforce that right away. And that caused performance problems that we didn't quite enjoy. So we've now kind of stepped back. And that ability for us to see things that are different on the core CLR side and the full CLR side and really align them better is actually turning out to be a really useful benefit for both the full desktop and core CLR. The other thing that really has made a big difference is this notion of a transparent library. The full desktop has a security model called Code Access Security. It's a very fully featured, very rich security model, but it's very complicated. And transparent code in this new model makes reasoning about security much easier. It starts off at the bottom where you have security critical code. This is code that's doing something that is fully trusted. So you might be calling into native code using p-invoke features or changing global state of an application. And it's at that level that you trust anyone who calls you. And so a security critical function doesn't necessarily need to verify its inputs. Whereas safe critical code plays that bridge, where safe critical code should always validate the inputs to its functions. And then lastly, transparent code, which lives outside of the Silverlight framework. And so this is something that you would download in your ZAP file or any library that you would get, such as Link. And that code can call any other transparent code or just safe critical code. And that led us to another ability, which is to actually factor out parts of the libraries outside of the Silverlight download. In the .NET framework, we would have included everything from LINQ to parts of the dynamic language runtime, and include that in the framework. In this case, we optimize for the better install experience of Silverlight. That's hopefully driving up more downloads of it and getting us closer to ubiquity. But now we're asking application developers to pay the cost of using any of these libraries. So it's more of a pay for what you use model. And see also additional UI components that are part of the Silverlight SDK are also transparent libraries. Then other CLR features that made a difference, taking the notion that RIA applications are interactive applications. So we don't need all the server scenarios or computationally focused features. And so for the JIT, we use minimally optimized code, because optimizing code when you are loading an application slows it down. And so this gives us the ability to optimize for load time performance in that interactive scenario. In garbage collection, we have two different sets of tunings for that on the full framework, just the server scenario and the interactive client scenario. So in Silverlight, we only have the interactive client. In reflection, there are a few features that remove that, such as removing support for modules. And then lastly, another area is where we could take out data from the core CLR and use what's on the operating system. So in the full framework today, we have collation tables that help us understand how to sort in different locales. And then in Silverlight, we're able to go directly to the operating system to get those tables. And so that does mean that there could arise some differences between Windows and Mac OS. But those are still based on standards such as Unicode, so those shouldn't be a big deal, but it does help us reduce the size. And that's actually a learning that we're going to be taking into the full framework in our next version. Another change that we had to make was just helping core CLR avoid any conflicts with the full CLR. Being able to load the two into the same process. And this comes up in a number of cases, such as having exceptions. I need to make sure that the full CLR doesn't catch exceptions that core CLR threw, or vice versa. And so this is also a scenario that's also leading into some of our future investments. And so the very last thing that is different about core CLR is that it supports Macintosh. This is not something that we do for the full framework. If any of you have looked at the source code for Rotor, Rotor is a shared source implementation of the common language infrastructure. There's some very good books about it. It does have quite a bit of description of this PAL layer, which we call the platform abstraction layer. Core CLR itself, we want to keep as one code base. Again, that gives us the benefit of investing in core CLR and taking that benefit across all platforms, including Macintosh. And it also focuses any of the differences that might arise from changes in the underlying platform to these PALs. The last thing that helps here is that core CLR right now is only focused on x86. And so the implementation there is simplified because of that. As we need to explore other platforms, we could expect to see more changes to this hierarchy. And that leads us to where are we going in the future? Some of the features that we've learned from in building core CLR are making their way into CLR4, such as in-process side-by-side, which is helping our compatibility story for the full framework, as well as the simplified security model. We really have seen that this is much better than the code access security approach. And I mentioned the globalization tables. Things that you should expect to see coming in core CLR in the future are really those differences between the full framework that still are beneficial to core CLR. And so those are things like profiling APIs. I'm sure at least some of you have looked forward to that, and we hope to continue investing there, as well as code quality. We know that sacrificing code quality to improve performance at load time today is okay for now, but that's not always going to be okay. And the last thing I should say is that Core CLR is also used by other Microsoft platforms such as Live Mesh. And so we have additional scenarios that we think of with there, but I think what we're thinking of as Core CLR should be a black box that gives us the ability to update when we need to. And so if you have any questions, after the conference, you can feel free to email me. There's also an article, if you want to search for this, Programming Silverlight with Core CLR, that talks about some of the things I mentioned in this presentation. So with that, I have time for one question. Yes? So a good question. Really, any advice that we'd have for keeping the two together, both the Core CLR and the CLR code base in sync. And I would say a big part of it is testing. When we go off and forget to test one of the platforms like Core CLR or CLR when we're making changes to the other, it really is noticeable. And so that's a big part of it. So I would say right now, I have one last request for everyone, is there's some session evaluation forms in the back of your notebooks, and the gentlemen in the back of the room that have the red shirts are very eager to collect those from you, and I appreciate any feedback you have. Thank you very much for coming.